small problem now here on the left side is that I don't know how to integrate this part, because this is 1 plus v by 1 minus v, and the degree of the numerator is always supposed to be less than that of the denominator, which is not happening here. So if the degree is not less, it's not a proper fraction, so we call it as an improper fraction, and so we try to do long division and try to make the degree less in the numerator. So how do I do that? I copy my numerator, which is 1 plus v as v plus 1 here, and then I divide by minus v plus 1 minus v plus 1. So every time you rearrange a polynomial, write it in the descending order. That's why 1 plus v is written as v plus 1 and 1 minus v is written as minus v plus 1. Then look at the first term is v, and look at the first term here is minus v. You will divide the first term from inside by the first term from outside. So v by minus v makes it minus 1. And with this minus 1, you multiply both the terms. So minus 1 into minus v is v, minus 1 into plus 1 is minus 1. And you subtract, so v minus v is gone, and 1 minus minus 1 is 2. So minus 1 is the quotient, and this is the remainder. So now we write the answer as always quotient first, minus 1, plus remainder upon the divisor. So from the division, you take the quotient and write it first, quotient plus remainder 2 divided by the divisor, which is 1 plus v. dv is equal to integral 1 by x dx. Now every single term is directly integrable. So when you try to integrate this, this is what we got in the earlier step. Integral of minus 1 plus 2 by 1 minus v dv is equal to integral of 1 by x dx. So when you integrate, minus 1 becomes minus v, because I am integrating with respect to dv with respect to v. So minus 1 becomes minus v. This is 2 times integral of 1 by 1 minus v, 1 by x plus b pattern. 1 by x is ln mod x. ln means log to the base of e. So you could write log mod x to the base of e, or ln, natural log ln. ln of 1 minus v divided by minus 1. Why is it divided by minus 1? 1 by x is ln mod x. So 1 by a linear expression ax plus b would be ln mod ax plus b, and divide by the inner derivative, which is a. So here 1 by 1 minus v is ln, natural log of 1 minus v divided by inner derivative is minus 1, is equal to integral of 1 by x is log mod x, natural log mod x, ln mod x plus c. Here, when I wrote ln x, it is actually log x to the base of e. So you could just write log x instead of ln x. So my answer here is minus v, which is minus y by x, plus and minus becomes minus 2 ln or log mod 1 minus y by x is equal to log mod x ln mod x plus c is my answer. We look at another question. Solve the initial value problem. So what we did earlier was the general solution, and now we have an initial value problem. That simply means that you have an additional condition given here. So you will find the general solution and then try to find the value of c using this given condition. Y of 1 is equal to pi by 2, which means when x is equal to 1, y is pi by 2. Let's try to solve this. First thing is I try to roughly see whether this is a homogeneous one. If you have a trigonometric function and if it involves y by x, then it is for sure it's a homogeneous differential equation, because you already have y by x terms appearing, and this format always would continue to be there. Sine of y by x, I cannot rewrite it in any other form. and therefore this is definitely going to be homogeneous differential equation. So I am trying to make this with dy by dx as the subject. So first thing is I keep the dy by dx term on the left side, and the other two terms I shift to the right hand side. So plus x appears on the other side as minus x, and this negative term appears on the right side as positive. Now to make dy by dx as the subject, I divide both sides by x sine y by x, which will give me only dy by dx on the left side, and the right hand side I individually divide the terms by x sine y by x. So the first term was y sine of y by x, I divided by that, then minus x divided by x sine y by x. A little bit of simplification would give it as dy by dx is equal to, here sine y by x and sine y by x cancels, giving me only y by x. Here x and x cancel, so giving me 1 by sine of y by x, which turns out to be a function of y by x, and therefore it is homogeneous. So now since it is come as a function of y by x, I call y by x as v. So we say let y by x be equal to v. Cross multiply, y is equal to vx. Then we differentiate with respect to x, and that's what we get by product rule. Y becomes dy by dx, this is product rule. V into first function derivative of x is 1, so v, plus second function x into derivative of v is dv by dx. So I make this substitution into my question. So my dy by dx would become this, and this would become v minus 1 by sine v. So my original question, my equation number 1, which is this, is now going to be v plus x dv by dx is equal to v minus 1 by sine v. And this, on further simplification, I realize that v and v will get cancelled from both sides. So what I have is only this, and then I cross multiply both the ways. The sine y comes to the left side and dx goes to the other side, so I get sine v. Sine v comes to the left side, so that is sine v into x dv, and this by dx goes to the other side, giving me minus dx. The variables are still not separated, so I shift this x to the other side, so that gives me sine v dv is equal to minus 1 by x dx. Now I integrate both sides. So when I try to integrate it, sine v integral is minus cos v, minus sign stays there, 1 by x is log x, 1 by x is log x to the base of e, or ln mod x.